Today's lesson is on graphing cube roots. So we're going to kind of start off at the beginning like we did yesterday. The index is no longer going to be 2. My index will now be 3. My starting point for my parent function will still be 0, 0, but more specifically, my starting point is going to be h, comma, k. So we'll be able to see that from our graph, or sorry, from our equation. So let's take a look. Let's graph a cube root function. So that would be something like y equals the third root of x. I know that my starting point is going to be 0, 0. And I'm going to come over here and I'm going to make a table. I do know that I want 0, 0 on there. And I'm probably going to want 1. But with cube roots, we can do negatives. So I'm going to do a couple of negatives as well. So I'm going to start off with these 3. So the cubed root of 1 is just 1. So I could go ahead and graph that. The cubed root of negative 1 is negative 1. So I'm going to go ahead and graph that. But right now, I could draw a whole bunch of different lines. Like right now, I could just draw a straight line through all of these. So I'm going to need some extra points. So just like yesterday when we were looking for perfect squares, this time we are going to focus on perfect cubes. And honestly, the easiest way I've found to do this is to pick whatever the next y value would be. So for example, I'm probably going to want the next y value to be 2. And then over here, I'm going to do 2 cubed, which gives me 8. On the other side, the same. The next y value I would want would be negative 2. So I would do negative 2 cubed, which gives me negative 8. So this is going to be kind of our standard starting point. So now I'm going to come to 8, comma 2, put a point. I'm going to go to negative 8, negative 2, and put a point. And this is going to kind of come into the middle and curve and change directions like that. So that's going to be our parent graph. Once again, we're going to save the characteristics for the next lesson. Okay. So I believe these were all square roots. They were. So let's look at some cube roots. All right. Got the cubed root of x plus 2 plus 3. My parent function is going to be the cubed root of x. So my normal starting point would be 0, 0. However, I know that my new starting point, there's a couple of ways we can do this. We've been doing this with the table, but we know that our starting point is h, comma, k. So in this case, my h value is the opposite of 2, so negative 2, and then k, which is 3. But let's go through and just kind of make sure that that ends up being true. So for our transformations, whatever's underneath the radical, remember we do the opposite. So instead of going to the right, we're going to go to the left. So left 2. And then on the end, we've got that plus 3. So it's going to move up 3. So what I could do, what I did yesterday or in the previous lesson, is I had my x and y. I started off with my standard parent function. So in this case, we've got a couple more than usual, but that's fine. So here's where we started. So what I did was I took the moving left 2, so I'm going to subtract 2 from all of my x values. And then the up 3, I'm going to add 3 to all of my x values. So that is going to make my new table -10, 1, -3, 2, -2, 3, -1, 4, and 6, 5. So we can see that my starting point did end up becoming -2, 3, just like we determined with our HK. So either way is totally fine, but the one thing that helps with the table is that you can now graph multiple points. So let's see. -10, 1, that's going to be further out, so I'm not going to do that one. I'm going to do -3, 2, -2, 3, -1, 4, and 6, 5. So it's going to be something like that as our new graph. All right, let's try again. So my parent function, y equals the cubed root of x, starting at 0, 0. Transformations, so inside the radical, I've got -1. We do the opposite, so that's going to go right, 1. Then on the end, I've got -2, so that's going to go down 2. So again, I'm going to start off with my kind of standard chart. And then I'm going to move right 1, so I'm going to add 1 to all of my x's. And down 2, so I'm going to subtract 2 from all of my y's. That's going to give me a new table of -7, -4, 0, -3, 1, -2, 2, -1, and 9, 0. So I'm going to come over here and graph that. So -7, -4 would be like about right here. 0, -3, 1, -2. Oops, sorry, I did that wrong. 0, -3. 1, -2, 2, -1, and 9, 0 would come out here-ish. That's probably a little far. Maybe there. And now I can connect those. So obviously it's not quite perfect, but it's close enough. All right, let's do one where we have something other than just left, right, up, down. So parent function, still the same. Cubed root of x. Starting point should be 0, 0. Actually, I don't think I ever wrote my new starting point. 1, -2. Okay, so according to our rule, our HK tells us that our new starting point should be, whoops, I lost my pen, should be 5, 3, but we will see if that happens. So let's start off in the middle again, just for consistency. That -5, we're going to go the opposite direction, so we're going to go right 5. That plus 3 on the top tells me I'm going to go up 3. And then I have this negative out front. And remember, the negative means that I am going to reflect over the x-axis. So, start my table. X, Y. I start off with my standard x values, my standard y values. So for my shift right, I'm going to add 5 to all of my x values. And then I'm actually going to go ahead and do my reflection, because that means I need to multiply by -1 to get it to the other side. And we always want to do our multiplication first. And then I'm going to add the 3 to move those points up. You could technically go ahead and add the 3 and then flip it. It's totally up to you, but I prefer order operations. So, all right, so new table, x, y is going to be, let's see, -3, 5, 4, 4, 5, 3, 6, 2, and 13, -2 plus 3, 1, 13, 1. Okay. So we're not going to be able to plot all of these just because my x values don't go that high, but that's okay. We'll be able to get a general sense of things. So -3, 5, 4, 4, 5, 3, 6, 2, and then 13, 1 would be somewhere out here. Oops, and then we will, that was not the greatest, but it's okay. So it'll be something like that. Does not have to be perfect. Mine never will be. But it's just kind of giving you a general idea of what it's going to look like. All right, now let's answer these last 2 questions about cube roots, and then we will be done until our next lesson. So remember yesterday we finished, or last time we finished with writing out a function based on the description. So we're going to start that again, but with cubed roots. So it says that the parent function cubed root of x is compressed vertically by a factor of 1/2, has been translated 5 units right and 2 units down. So we're going to start off with our standard with the cubed root of x. Doesn't matter where you start. We've been starting with what's underneath the radical, so let's go ahead and do that. If we're moving 5 units right, remember we have to write the opposite sign. So that's going to give us a -5. 2 units down, that goes on the outside. We're going to go -2. And then it's been vertically compressed by a factor of 1/2. So remember, the compression or stretch goes out front. So we're going to put that 1/2 out front. So our function would be f of x equals 1/2 the cubed root of x minus 5 minus 2. I just realized these should all be g of x. So this should be g of x, my bad. We'll fix it for the next one. G of x. All right, and we'll do it right for the last one. So g of x, and we're going to have cubed root of x at some point. All right, so for D, the parent function is reflected across the x-axis and translated 7 units up. Okay, so that means there's no left and right, so I actually don't need as long of a tail on that radical as I had. 7 units up, that's going to go on the end, that plus 7. And then remember when we reflect, we put a negative sign out front to indicate that we are flipping over the x-axis. And that's it.